It's great to be here, and it really was memory lane driving back down the motorway. It's strange. I did it for sort of 5 years of my life, 80 miles each way, and you just sit in the motorway and you drive along and you think, okay, if I totaled up the number of hours I wasted commuting, it's kind of scary. But it's great to be down here, and fantastic opportunity. I really appreciate it to talk to you a little bit about Google Maps and perhaps offer you some sort of behind-the-scenes context of what we think about when we work on Google Maps. And particularly what I want to talk about over the next 40 minutes or so is the redevelopment we've done around Google Maps over the last year, and to sort of think through the thought processes. How do you take something that's been quite successful and change it and respond to user feedback, go through that process? A lot of it trying to understand how we can use the technology platform that's now available to us to better communicate what we call geospatial information, or geography, basically. Now, to put all of this into context, I want to talk just a bit about Google and our mission statement. Everything that we do is basically boils back down to this mission statement that we have at Google, which is to organize the world's information. And yes, you know, we spend a lot of time worrying about advertising and using that as a mechanism basically to pay for this. And every product, every service that we offer, all is based upon this idea of there is a huge amount of valuable information on the web today, and we still struggle to find it. You know, we're getting better, but you know, web search is certainly not a problem that is solved. And one of the ways that we can help to organize the world's information, to make it more useful, to make it more accessible, is to use geography. We use geography as an organizing principle to say, okay, we're used to sorting numerical data or looking at alphabetical data or historical data. Another way that we can look at organizing information, managing it, is to look at where it is. And that has been very powerful. Now, I unfortunately have a bit of a bad reputation. This is an article that was published last year that says, I am the man from Google who makes maps obsolete, which is a bit hard, a bit harsh, I think. Maybe there's a little bit of truth in this, so I like getting an argument going, particularly about traditional cartography. But the basic principle here, and it's a narrative that you'll hear a number of times, is that paper maps are dead. As a result of that, none of us can navigate anymore. We're all going to get lost. You know, come a time when our phones don't work or electricity is broken, we're all doomed. And okay, maybe there's an element of truth in that, but actually what we're seeing is a natural progression. We're seeing the advantages that digital data, information on the web in particular, has over traditional publishing methodologies, and particularly paper as a medium for cartography. More accurately, perhaps, then, as we're looking at a situation a bit like this, where you know, the paper map produced by our friends at Ordnance Survey just down the road, as Alan said, not going to disappear in the same way that vinyl albums have not disappeared. If anything, there's a sort of little bit of a minor resurgence. One of my teenage daughter's friends has just bought what she calls charmingly a gramophone player that she plays vinyl records on. But this is going to be niche. Paper maps are going to be increasingly niche. They're not going to disappear, but they're going to be something that is perhaps less used, only really used by the enthusiasts. But obviously it's not all doom and gloom, because actually we're living in a time now where maps are more widely used than they have ever been at any point in our history. And as cartographers, people involved in mapping, we're very proud of this. They are more widely used because they're more accessible. No surprise there. They're more accessible because we have them on our devices that we carry around with us. I now have a tablet as my corporate device. I don't use a phone anymore because nobody used to phone me. I've sort of given up on that bit. I just now carry a tablet. But my tablet has maps of the globe. I can get access to maps of anywhere, whenever I need them, and they're much more powerful, more usable than the traditional paper map, obviously. So that's really the context of what we're talking about. The other thing that has changed is that the maps that we use are part of the web. They're part of a network architecture. We're all very familiar with the underpinnings, the mechanics of how the network works. We all know about, IPv6, and we understand about the issues of, old routers not being able to allocate IP addresses, blah, blah, blah. But there's a more, I think, valuable thought about this idea of a network architecture, and that's the word architecture itself. In one way, it means, how do we design, how do we plug things together? What's the plan? But a more, I think, useful meaning of architecture is that it's a principle. It's a shared aesthetic. We think about architectural styles of buildings. You think about, Palladian architecture, or you think about Georgian architecture. There was a kind of a shared view of approaching a problem. And that architectural approach is something that is increasingly important, I think, as we move forward. Because many of the world's problems that we are going to have to face only really work at that scale of a global network. They need a thinking that is global in terms of getting access to materials, resources, users, data, processing capability, only at that network scale. And let me give you an example of what I mean by this. A solution that only works because this network exists. And that's simply Google Maps on my mobile phone. Now, if you've been driving on the peninsula in San Francisco or driving from Mountain View up to San Francisco, this will be something you may well see quite regularly on your phone. It will come up, it will flash, a card will appear, and it will say, there's now a faster route available. It will save you 10 minutes. Click this button, it will take you on a different route. We take this for granted, how this capability is now available to us. But how does that work? It works because there are many, many users of Google Maps. There are 1 billion people that use Google Maps every month. But a number of those are actually contributing information back. They're choosing to share their location anonymously so that the average speed or the actual speed on any particular section of the road is being measured, and that information is then being cycled back into the navigation capability to say, okay, we now know that this road is going to take a bit longer than it would do normally, and we're going to recalculate. So there's a kind of a positive feedback loop there. The more people that are using the application, sharing the data, the more useful that application gets. That only works because of that network of users. Likewise, it only works because there's the processing capability of lots and lots of servers around the world, equally accessible for people to make use of. It allows us to do crazy things like this that are almost magical when you think about them. Imagine you're in a restaurant in Moscow. Someone presents you with a menu in Cyrillic. You can't read Cyrillic, but you can scan it using your phone. Once you've scanned it, you just draw your finger across the word that you want translated, and as if by magic, Google Translate tells you what that word is. Okay, so that particular menu item is Ukrainian borscht, not something you're going to get very much in Moscow these days, but it was probably appropriate for when we put the slide together. What's happening is behind the scenes, all of those computers are doing optical character recognition, working out what I've dragged my finger across, and they're doing the translation based on machine learning, on pattern recognition, not through any real syntactical knowledge of Russian, but actually understanding those patterns as they've emerged. It's a big computing problem. So, given that context then, if we've got this great network architecture available to us, many, many users out there, great computing processing capability, where does Maps fit into that? Where is Maps useful? And why on earth would you want to reinvent Google Maps, something that has been working very well? This was obviously the question we asked ourselves. If it ain't broke, don't fix it. 1 billion people can't be wrong. Well, maybe. well, maybe they weren't wrong, but we need to improve. If you don't cannibalize your own business, someone else is going to do it on your behalf. Technology is always moving forward. Our expectations of what technology delivers are always moving forward. But most importantly, honestly, we stepped back and looked at Google Maps. This is what Google Maps used to look like a year or so ago, 2 years ago. And there's a huge amount of information there. We'd argue no one has a richer set of data content on their maps. But that was the problem. There was just too much information there. And like most applications that have been developed over the web incrementally over any period of time, we'd added more and more functionality on, both in terms of then an increasingly complex code base to look after, but also from the user's point of view, it was getting more and more complex. You're going all over the screen to find different controls to get access to different bits of functionality. So although we assumed, yes, it's great, everyone's using it, but if you step back, well, actually, it's amazing that everyone is using it because it is really quite difficult to use, difficult to get your head around. So, time to redesign. This is a really important principle that I think, as technologists, we've often forgotten. Certainly cartographers. I'm not saying in the general visualization community this has been the case. But for cartographers, probably this has been. Cartography is all about what you take off a map, not what you add. Now, might sound obvious, but actually that was quite a radical statement to say to the cartographic community a year or two ago. Not what you add, but what you take away. As cartographers, we really did know this in our kind of DNA, although here, the great example here, this is Harry Beck's initial design for the tube map, that great example of an abstraction of reality, a simplification of reality to communicate. The great example that we always point at, Harry was not a cartographer, Harry was an electrical engineer. Kind of hide that fact, a bit embarrassed by that, but never mind. What he did was a great abstraction to say, okay, what's really important actually is the topology of the network, i.e. which stations are connected to which other stations. Their actual absolute location is not important. It's actually how they're connected that's really important. That's what we need to show on our map. Where we've gone, and I'm not having a go here at OpenStreetMap in particular, we're all guilty of this. Where we went in web mapping was just to throw as much stuff on the screen as possible just to prove that we've collected that data. You end up with a really complicated, busy, confusing map that actually isn't communicating anything in particular. Every map that we create as cartographers, we are creating to tell a story, to inform our users about one aspect. There has to be a design principle, an aim behind each map that we create. Our maps became so generic that they were just shouting at us. We needed to change. We also needed to change because the technology had changed. Remember when this was really exciting? We say, oh, AJAX, yeah. And we'd run around saying, oh yeah, we've built an app that makes use of AJAX. And obviously, Google Maps in its time was that great example of the AJAX app that you used to show people. But actually, obviously, time has moved on. We have now these great platforms that we can build on that allow our browsers to be every bit as powerful as traditional native applications would have been only a few years ago. But it does need us to think differently, to think about, okay, what can we do on a browser now that we have this capability? Those restrictions that used to be there aren't really there anymore. The other big change is that now most of our users are going to be using our map application on a mobile device. How much of a shared common code base can we use to make sure that whatever we develop works well on all of those different platforms? We're not going to be guaranteeing that someone is going to be using a laptop. Increasingly, they're not. There's another important element to our thinking that maybe is quite specific to Google, but I think it's quite valuable for us. We have this idea of moonshots, of 10x thinking. We say, well, what we want to do is when we make a change is not just do something incremental. Incremental change is like business as usual. When you want to redesign something, don't just make it 2 times better or 3 times better. Make that big leap. Make it 10 times better. Really challenge yourself. Ask yourself really awkward questions. Make perhaps mistakes in the process. But have a big challenge. Don't just go for the incremental. Jump, make a leap, go for the moonshot. And that's what we've tried to do with maps. Our 10x thinking, the big leap, the big ask that we made was this. With the new version of Google Maps, every map that our users see will be unique. It will be rendered specifically for that particular user, for the particular task they have in mind. No 2 maps that Google Maps create now will be the same. Every map will be unique. That was the big ask. That was the big leap. That was very radically different to the traditional cartographic approach. So we did loads of work. You know, you'll be very familiar with this idea of wireframing and whiteboarding the designs, trying to think about basically 2 major design issues. One, what did the map look like? What we perhaps traditionally call cartography. And then how did you interact with the map? What was the user interface? And that's something that, to be honest, historically we worried less about. We'd all kind of got to this idea that every map will have a magnifying glass on it, because everybody knows a magnifying glass is kind of zooming in. And then you have a hand to move, because everyone kind of accepts that's the way that you pan a map. But really, should that be the case? Are there not other ways that we can look at interacting with the map? Here at a very high level is how Google Maps changed, the before and after. The cartography clearly has changed between the 2. The map looks different. The other thing that you'll notice, and a key challenge that we wanted to work on, was to remove all that wasted space. About 1/3 of the screen was permanently a sidebar where we'd show other information at some point when it was relevant, but a lot of the time it was just wasted real estate. And it didn't really work in that context of mobile devices either. So at that kind of high level before and after, these were some of the big kind of changes that we did, that we adopted. We also wanted to embed Google Earth. We wanted to move Google Earth from being a native application into a browser-based application. So we said, rather than having a traditional kind of aerial photography view, let's make Google Earth the aerial photography view. That was the other big change. Okay, so let's dig into this in a bit more detail now. The new cartography, let's look at those differences in maps. Here you have maps of the American continent, and they're both trying to display basically that high-level view, showing you where the countries are. But the old map just literally showed you where the countries were. With the new one, we brought more of a kind of traditional atlas aesthetic that gives you some idea of both the relief and the type of vegetation that you'll find in those particular parts of the world, you know, at a very broad scale. But why wouldn't you show that? It's easy to show that. Historically, we hadn't done that because the data that we used initially was just boundary data. We hadn't thought through, well, why not display a bit more? At that kind of broad scale, yes, you could argue that this is prettier, perhaps it shows you more information. But really, the difference came when we started looking at the kind of types of maps that most people use Google Maps for every day, and that's the idea of the street map. And for everybody involved in digital cartography, at least sort of 5 or 6 years ago, maybe 10 years ago, we were all based on the same data sets. We were all reliant on digital versions of traditional street atlases like the London A to Z that you'll be familiar with in the UK, or databases that had been created for personal navigation devices. And those databases obviously were focused on roads, street networks. And that's, you know, a key capability of your map. But we got to the point where the road network was so dominant that it was taking over the map itself. Here we are looking in downtown San Francisco between the old style cartography and the new style cartography. Now, hopefully, you can see and understand much better the hierarchy of roads using this new style cartography than previously. Previously, we were again focused on, we got to make sure every road's there, every road is clear. But one of the really important principles in cartography is about hierarchies and understanding the relative importance of different types of roads. Hopefully, the new version kind of better gives you that sense. If you've got these major highways that kind of thread their way through downtown San Francisco, and then you've got a very dense network of kind of residential roads. The other thing we wanted to work on was to try and make our maps consistent. And this has caused huge amounts of grief and internal gnashing of teeth and banging on walls and argument, particularly here in the UK. In the UK, the old version of the map, we had blue motorways because everybody knows motorways are blue, as long as you're not French or German or from the United States, almost any other country where motorways are a range of colours. So we had this kind of European level view where it got really confusing, and particularly if you were going across the boundary, say, between Belgium and Germany or Germany and France, things just change colour for no apparent reason, other than that was cartographically what people were used to. And again, it doesn't really give you that sense of hierarchy as well. Blue roads being a different colour to trunk roads doesn't give you that sense of this is a main road, this is a trunk road, this is a minor road. What we did actually was to take as inspiration a leaf. A leaf, you get that sense of the structure of a leaf because it's all one colour. Width is used because physically the width of various elements of the leaf are different. So looking just now at the UK here, to the area around London, you've got a kind of split screen going on here between the new cartography here, where we're all based on different kind of colours of yellow and orange, and the old cartography where motorways were blue and all the other roads were different colours. Now hopefully you see that that gives you a better sense of those different types of roads. This, if you're more familiar perhaps with UK maps, looks more natural. And you know, we went through a dodgy few months perhaps when there were lots of people going, oh, hang on, what's going on here? It doesn't look right. But people have come to accept it. Because I think fundamentally it gives you that much greater sense of clarity over the different types, the different scales, the hierarchies of roads. Now, this is, I think, where we've made the biggest leaps and where, for cartographers, this was most important. This is probably, and there's a lot of argument about this, this is probably the oldest town map anywhere in the world. This is of a town in Turkey. It's about 8,500 years old. And if we're really honest, the techniques that we've used in cartography haven't really changed much in those 8,500 years, where we've gone from writing on cave walls to etching to printing on paper to ultimately producing maps that will appear on screens. The underlying techniques haven't really changed because we haven't made that mental leap to say the media is radically different. To be honest, there's not that much difference between writing on a stone and printing a map. The media is, by its nature, static. As soon as you make the map, it's fixed. Because it's fixed, it has to be generic enough that it's available to a wide community because we can't print maps individually for each person. That was our mindset, despite the fact that for at least 20 years, the media that we were designing the maps for was very dynamic. A lot of those constraints, those restrictions that we had with paper or stone tablets were not there anymore. So I'm going to take you through a few examples now of where we've kind of said, okay, let's break the rule. We can make these maps dynamic. We can make them individual because we can. The media of electronics display allows us to do that. So the first use case then is I want to meet you at Pullen's Gardens. Pullen's Gardens is one of these kind of charming Victorian spaces near Vauxhall. It used to be part of Vauxhall Pleasure Gardens. And if you go and look in Pullen Gardens on Google Maps, traditionally, that's what you would have got. There's Pullen Gardens in the center. You typed, I want to get to Pullen Gardens, and we put a little red pin there to show you where it is. Now you can say, well, that's unique because that pin is there. And what we did to kind of get over that limitation of not making the underlying map change was drop pins everywhere. There's the map of Pullen's Gardens. But if you think about it, that map contains a lot of information about the Manor Place depot and the fact that there's a, you know, that hotel over there. Is that really relevant to a map to show me the location of Pullen's Gardens? How might we do it in other ways? Well, obviously, you think about kind of location maps. What you end up doing is you get a napkin and you scribble on that napkin, this is how you get to Pullen's Gardens. And what you're doing in drawing on that napkin is you are abstracting. You're saying, okay, I've got a good idea of this neighborhood, but these are the things I'm going to show you that are the most important elements for you to identify the location. Pullen's Gardens is going to be in the center. These are the main roads that lead to Pullen's Gardens. Maybe these are the landmarks that are important to you. That's the sort of process that you go through when you're using these kind of napkin-style maps. What we could then do is say, okay, well, we can kind of abstract out and say, okay, let's do the digital version of that and only show you the roads that are relevant to you to get to Pullen's Gardens. But that doesn't really work very well. We lose the context of all the other streets that are nearby. And how do you know what are those really important roads? You can do it by, you know, geometry, intersection. You know, which roads are connected physically to Pullen's Gardens? Are those the roads that we need to display? We can be a little bit cleverer and say, well, actually, we know that the roads that people travel, because we can track anonymously people's mobile phones, we know the roads that are important, the roads that people will travel in this particular neighborhood. Can they give us a sense of the roads that are most important? Can we combine those together? So we got some of those principles together, and then what we do, and I guess what you all do, is you iterate. And here's some iterations around how do we do this? How do we identify a map that is specific to a particular location? Here is the first iteration, number one here. It represents fading back as much as possible other roads and only highlighting the roads that we think are important in the neighborhood. But then, again, from that previous example, you kind of lose context a little bit. The other example was to use quite radical differences in color, have quite bright roads that represent the area that's important to you. And again, that kind of works, but then you have that automatic connection between bright roads, color, being associated with the importance of those roads. And sometimes these roads aren't that important in terms of they're not big major roads. We're trying to say they're important for this particular destination. Other things we try were all sorts of kind of animation techniques of having dots dancing around the roads. We can do this now. We can make animated maps. That didn't work so well either. That kind of distracted people. So this is what we've come up with. And if you use Google Maps today and you ask for a specific location, this is what you'll see. What we've done is to fade out some of the roads. Actually, we faded out all of the roads apart from those that we think are relevant to getting to that particular destination. So you've got the context, but we said, okay, these are the roads that are really important. And if you look at the before and after, it's quite subtle in some ways. The underlying cartography has changed. We can physically change what the map looks like. We're no longer baking tiles that always look the same. And we're dropping some content. So you can see that that manor place depot, that's not really relevant. You know, it's not something you're going to use as a navigational feature. We can drop that. We don't need to display that to give you that sense of this is what's important. Okay. Next thing to look at is here are some lovely, shiny, young people using their mobile phones. What I'm trying to get across here is that traditionally, if they've pulled out their mobile phones and gone to ask for a map of Pullen's Gardens, everyone's map would have been pretty much the same. But why should that be the case? Maybe sometimes that's useful, but actually they all have different expectations, different preferences, different ways of viewing the world. Why not represent that in our maps as well? An element of customization. Now, for this to work, you need to have logged in to your Google account. You don't have to log in. If you don't log in, you don't get a personalized map. That's fine. I'm not going to force you to do it. But if you do log in, the map that you see will be unique to you everywhere. Some areas it's going to be more different than in other areas, but it will be unique to you. And this is my map of New York. Well, this actually isn't my map of New York at the moment because I've not logged in. You can see it says sign in at the top. This is my generic view of New York. If you hadn't logged in, you'd see exactly the same thing. But if you do log in, and again, this is very subtle, you get a different map. And what we're doing here is highlighting different places that I or my friends or family have visited. And I'll flip between the two. You'll see the differences perhaps a bit better if I do that. Before and after. Now all you're seeing are different features. So my son is very keen on the donut pub there in Midtown. Great destination to go to if you're in New York. A pub of donuts. How could you not like that? Great. And other places that I've visited over time, places I've checked in, places I've searched for, hotels I might have booked, airports I might be flying from, they will be highlighted on my personal map. Makes the map more relevant, more personal to me. The next thing then is moving away from cartography to think about, okay, what about the map as an interface itself? Now, in the early days of web mapping, the map was a backdrop and you interacted with it with kind of simple controls. But why not make the map more interactive? Why not actually make the map the interface itself? That was a big leap that we had. Now, a lot of the slides I'm going to show you now are a result of our internal dog food process. We all, in Google, dog food our products. You know, the saying being you should eat your own dog food. Never quite sure where that came from, because I don't know anyone that eats dog food. But you eat your own dog food to prove that your application, that your program will work in the way that you expected it to. And you'll find out issues with the design, with the workflow, and so on. So let's go through a couple of examples again. The first of which is finding a pub near Oxford Street. Now, this is Oxford Street in Sydney. Our Australian friends here in the audience will appreciate this more, which is a great destination for finding a pub. There's your traditional view of finding a pub. Oxford Street has got loads and loads of pubs and bars, and what you might find traditionally would be a load of pins appear on the map, identifying bars as a result of us doing search of our local index of bars and restaurants and so on. And what you would have had then on the left-hand side of the screen would be a list of those bars that you could scroll down through. What we wanted to do here, and again this was radical, was to kill the pin. Enough of these pins littering our maps. The maps should show you all the information that you want to see. You shouldn't rely on there being a pin added on top. The map is itself dynamic, so why not change every map to represent what you're looking for rather than dropping a load of pins on the map? So again, let's iterate through this process. number one, what we thought about was, why don't we just draw simply red circles around the map to show you where the bars were. That kind of works. But again, remember we have a hierarchy at work here as well. When you search for something, we show you a list, and that list is based upon an algorithm. We think the top of the list is going to be more relevant than the bottom of the list. So we need some way of representing that hierarchy as well. We thought maybe we could do that by stars. You know, this is a better bar, that's a worse bar. That looks quite cluttered. We also had other information. We pulled out kind of snippets of text that will tell you a little bit more about the bar, because with bars, restaurants, hotels, and so on, the name on its own isn't usually that useful. We want to find a little bit more information as well. So how can we combine all of that information together to say, okay, these are bars, these are the names, these are the kind of categorization of them, and these are the relative values of them in terms of those stars. So this is what we've come up with, where we have icons that represent different types of business and different types of text, bold text with a name, and then a little bit of text underneath that gives you a sense of what's special about that particular bar. It gives you a sense of place that's really important. There's lots of bars here, not just the ones that necessarily are at the top. You've got those little dots there representing where all the other bars are. But we've highlighted some in particular. Again, if you look at the before and after, I think this is kind of less of a huge win for us. I think there's probably still more work to do here. But I think we are extracting more useful information and presenting it in a simpler way to our users than previously. And obviously, as you interact with these, you get more information. Get rid of that horrible left-hand bar thing as well. That was a big challenge. How do we do that? And it was just wasted space, because it's the same information that you get when you click on any one of those pins. But how do you do that better? Again, let's iterate. This is where we had some really crazy ideas. Well, we can pull up a lot of the underlying database content that we have as this kind of floating panel associated with each bar as you click on them. That we thought was maybe a bit too aggressive, maybe a bit too much content. Other idea was this kind of line, kind of a traditional cartographic call out to it. And then this is the craziest one of when you click on it, the rest of the map kind of grayed out, and you had this then circle around it with text round the edge of the circle giving you the information. That was just showing off, to be honest. You don't really need to be able to do that. What we've come up with is a kind of a compromise in that when I click on a particular business, in this case, this is my own neighbourhood, Teddington in southwest London. If I click on a particular business, up pops that panel in a consistent place. It always appears in that same place. And when I click somewhere else or I click off the map, that panel disappears. So it's a kind of a compromise. It's saying, okay, you're used to looking over on the left-hand side for that attribute information about a particular bar. We'll still have it there, but we'll make it dynamic. It'll appear and disappear depending upon what you're doing on the rest of the map. Now, to be able to do all of this kind of crazy on-the-fly cartography, the underlying change, I'm sure that you'll understand from a technical point of view, is that what we're doing here is we're mapping vector data. We're not taking traditional raster tiles that were the traditional web mapping approach and pulling them in using AJAX. What we're doing is we're taking a download of vector data every time you move the map around, and we're rendering that vector data using the very powerful capabilities of modern browsers. But there was a problem with that. And that problem was, it was perceived, and actually it felt slow. It felt slower than the traditional version of mapping. This is what we heard from our dog food users. It's too slow. And that's the kind version of actually what they were saying. The real version had a much more complex expletives in it saying it's too slow. What you might see if you weren't on a very fast browser, very fast computer, on a fast network connection, was something like this. How many people saw this in the version of Google Maps in the early days? You know, it would say Google, and after a few seconds, pom, the map would appear. What was happening behind the scenes is we were streaming all this vector data down into the browser, and the browser was going, okay, send me more, send me more, send me more, and then it would render the graphics. And depending upon the speed of your computer and the speed of the network, that could take a few seconds. It actually wasn't that different to the tiles appearing, but because apparently nothing was happening, it seemed to feel very slow before your map finally appeared. And it would appear like that. Bosh, there it is. So we were quite sneaky. What we did was to kind of change the rendering engine a little bit, go back and say, okay, let's tile the vector data and send those tiles, or even, if it's a really slow connection, send raster versions of those tiles while things are happening. While we're streaming all that vector data, we can send all these little tiles. At least something appears to be happening on the screen, and then you're there and you're ready for action. So are we tricking our users? We're showing them that progress is happening. And it may only take half a second for that vector data to appear and to be ready for you to get access to it. And chances are most people actually don't start panning around and don't start typing until something appears on the screen. They could have done. Actually, the search box at the top was active from as soon as you loaded the page. But people didn't do that until they saw something on the screen. So we have to show them something on the screen quickly. You only get that insight from watching people and talking to them and saying, okay, what's frustrating? Why aren't you typing something now? What's going on? There's a lot of analysis on actually how people interacted with our maps to get that insight. Out of all of the things that we changed, this was the thing that caused the most upset. The Pegman strikes back. In the early version of Google Maps, or the previous version of Google Maps, to get access to Street View, lovely, fantastic street-level immersive photography, you'd pull the little yellow guy off the menu, off the scale bar, and drop him somewhere, and you get a map. And conceptually, we always had problems with that, because kind of how does that work? Why would you have a little man sitting on top of a zoom bar? How is that logical for people? We thought, no, it'd be much better to actually have Street View imagery accessible via other images. So initially what we did was, okay, we have these kind of little set of graphics images at the bottom of the screen, wherever you were. And if you wanted Street View, you'd click into there, because that's where the images are. Seems logical. Did any other users do it? No. Didn't understand that at all. Everyone, where's Street View? Say, well, it's there, in the picture at the bottom. And nope, can't see it. It's there, look, you can see it. Nope, can't see it. All right, okay, fair enough. Let's think about something else then. There it was. Probably the problem was we didn't have a big orange arrow saying, look, it's there. The second approach then was to say, okay, when you search for something, when you click on a particular site, you get that panel appears. We'll put the Street View image there. There it is. You can see it's even got Street View written on it. No, that didn't work either. You say, where's Street View? So it's there, look, it's written on it. No, can't see it. It's not working. Don't like it. Where's Street View? Bring back Street View. Oh, it's there. So what have we done? There it is. There he is, the little Pegman. Now, if you want to get Street View, you click on the little Pegman. Look, I've even zoomed in. You can see him. And you can drag him, and you can put him wherever you want. The important bit there is, even though from a user interface design point of view, saying, well, there's kind of no logical metaphor for this, it would be much better if it was kind of informationally associated with the other information you're looking at. People had established a particular way of interacting with the maps. They understood that Street View was associated with a little yellow icon of a guy and they dragged him. That's what worked. So a lot of the changes that we made, that was fine. We could make those changes. We made the map simpler, quicker, dynamic. But some elements of the user interface, we had to go back to our little yellow guy. There he is. OK, final things to look at. I haven't spoken a huge amount about the Google Earth functionality that's there in the new Google Maps app. It's absolutely incredible. Driven, again, by that same capability that we get with WebGL and the accelerated graphics in our browsers. Our browsers is doing what Google Earth standalone application used to do. And the quality of the data is now radically different to what it was in the early days of Google Earth. This is the South Bank of London. It looks like a picture that you were taken from a helicopter. Is that photorealistic? Because every pixel on that image exists in 3D. Comes from basically flying over a city in a grid pattern, taking oblique imagery from every angle, then doing some soft photogrammetry, and it allows you, in effect, to create a 3D XYZ value for every pixel. So trees, cars, everything is there rendered in 3D. Fortunately, we don't have this imagery for everywhere, but we're working on it. And that brings us to my final points. And these are the kind of the three questions that we get asked around Google Earth. And this is maybe not directly related to how we design Google Maps or the cartography or the communication principles. But this reflects perhaps the biggest change that is going to impact our industry in the next couple of years. So what people used to ask was, can I see my house? How many people have used Google Earth? Hands up. Keep your hands up if the first thing that you looked at on Google Earth was your house. Yeah, OK, most of you. We all did the same thing. And what people asked us always was, can I see my house? And it used to be that if you lived in the West, America, UK, probably could. Now, about 98% of the world, where the world's population is, we have high-resolution imagery enough to see your house. So kind of tick, done that one. Next one was, is it real time? No, of course it's not real time. These are satellites that go over, blah, blah, blah. Oh, OK. If it's not real time, then how old's the imagery? And at best, today, on average, we'll say the imagery is about a year old. And that's kind of where we're at. That is all going to change. The biggest change that's going to impact our industry is going to be the availability of near real-time imagery. There are constellations of very small satellites being launched by lots of different companies now, and they have the ability to image our Earth in real time almost, and to be able to view things changing at a level of frequency that's just never been possible before. And there are going to be huge visualization challenges associated with that. I just want to show you, to finish off, a video of the capability that's now available to us. If I can click on here. Now, a lot of things are going to happen in this video, so watch carefully. This is the Burj Khalifa in Dubai. Now, you might see very quickly, there's an aeroplane flying across the bottom of the screen. The satellite is traveling north to south, so you might not be able to see it very clearly, but in the middle of the screen is the Burj Khalifa. And you can see the parallax changing as the satellite goes over. You'll see the shadow shifting. What you're looking at here is real-time video from space. Now, this is just produced from one satellite, so what one satellite can see is obviously limited, because it's kind of looking down. But you imagine constellations of literally hundreds of satellites, all networked together, all communicating with each other, covering the globe's surface with this kind of quality of imagery in near real time. So we're moving from a capability of basically taking a picture of the globe once a month, maybe if we're lucky, to being able to continually monitor any part of the world using real-time video like this anywhere on the planet. And this is going to be, maybe within the next 5 to 10 years, this capability will be here. What we then do to visualize, what we then do to how we change maps, is going to be a much more radical shift than we've done up until this point. Okay, that's all I wanted to talk about. I'm happy to answer any of your questions. Thank you very much.
Thanks, Ed. That was a really great start to this morning's programme. We're going to get a roaming mic sorted for people to ask any questions. We've got about 5 minutes for questions. While we're waiting for that to happen, there was one that came up on Twitter.
Oh, good.
Which and Baron Cobban said, and you're going to love this, he said, what about the old maps? Did you archive them, and are they available anywhere? Okay, I'll leave you to that while we get the mics.
I think you can still get access to the old version of Google Maps. You have to flick a few switches, set a cookie in your browser, and you still get access to the old version of Google Maps and all the data that's associated with that. But you know, in time, it will disappear. These maps are dynamic by their very nature. So you know, we haven't archived them in the same sense that you would archive traditional paper maps, put them in a map cabinet or a map chest somewhere. It will disappear.
Right, so I've got a roaming mic. I'm going to pass it to people who put their hands up.
Could you want to do your Elvis impression? Go on.
Thank you very much.
Thank you very much.
Could you say who you are before you ask your question? Thanks.
Okay, so my name is Jeremy Walton. I'm from the Met Office. So you're not archiving the maps. What about the satellite data? You're archiving that. Is it possible for us to look at the satellite images and take a trip back to see how our street has changed over the last 5 years or something like that?
Yes, we are. We're archiving both the imagery that we capture, and it's relatively new for us to be capturing imagery from aerial, from satellites, but the street view imagery, very recently we've made all of that information accessible via Google Maps. So you can go where there's the street view imagery and we have historical imagery, you'll see the user interface changes and you can slide back and look at previous imagery. Now, unfortunately, the imagery that we show you is the processed imagery, the imagery that has been blurred and subsampled and so on. The European Commission forced us to delete all the high-resolution imagery because it was perceived to be personal data. But you can get access to the data that's been published.
Hi, Cyril Concoletto from Telecom Paris Tech. You didn't talk about offline maps. And this is very, as a user, this is very frustrating because the experience is not the same in different countries and it's very painful. So.
Yeah, it's something that has always been an element of a challenge. Where we've got to at the moment, and obviously it's something that's much more relevant to the mobile version of Google Maps, so running on your phones. There is now the capability to kind of download the area that you're looking at. So if you search for example, Winchester, you type Winchester into your phone, it comes up with a panel of information. You'll have an option there to download this map. And it will download the area that you see on the screen and all the various levels of zoom. So you can zoom in and you can zoom out when you're disconnected from the network. What you can't do is to do search, because search relies on that ability to connect to Google as a search engine to carry out search. But in terms of using it as kind of a traditional map to navigate by, you can do that offline now. Give it a go. Maybe, and that's a fair point, maybe we don't expose that ability very clearly. And I'll show you how it works. I didn't design the user interface. I'm not going to take the blame for that one.
Okay, we've got a question. If we can just get the mic over.
Hey, I'm Ian. I'm a designer at Cancer Research. When you showed us when you were searching for that park, how it kind of cuts out the non-relevant information, it dropped that building opposite, but then it left in stuff like the hostel that was off in the distance. Is that based on the user who's using the map, how it decides what to cut, and are you kind of categorizing types of buildings and places and linking them and saying this is relevant to parks and this isn't? Or how does that work?
A bit of both. We're trying to identify what we would all recognize as landmarks, you know, buildings that are particularly relevant for wayfinding and navigating. Sometimes they're obvious, sometimes they're not. So we're trying to do that. There will be an element of personalization as well. You know, so if there are places that you have visited, they will automatically be highlighted because we judge that you will have a connection with those. You'll remember them, you'll know those areas better. It's, again, something that we're continually kind of fine-tuning the algorithm, trying to work out what do we show, when do we show it, how do we show it. And this is relatively new territory for us. You know, we've we've made that leap to say these maps can now be completely dynamic. Every feature can change. We're now just kind of tweaking the knobs to see how do we change them and get the most information across that's most relevant to an individual user. So that may well change over time as well.
When you pick landmarks, does that change how you pick them? Does that change by city? Because a lot of city mapping studies have shown that the way people navigate certain cities depends on how those are laid out and things like that.
Exactly, and the classic example we've been working on is that one of Dubai, where in Dubai roundabouts are really important because often the roundabout will have a name, but the roads around that roundabout haven't been named yet. So people will navigate, say, okay, you go to the roundabout by the Carrefour, and everyone knows that that's that particular roundabout. And that is a kind of a thing that's unique to Dubai, and therefore we need to understand that when we map that particular neighborhood.
Yes.
Great. Thanks ever so much, Ed. That was a great start to the morning. Thank you very much.